I'm going. Okay, so we're classifying polygons, and your objective is to be able to classify polygons. Okay. The definition is if a polygon is convex if no line that contains the side of the polygon passes through the interior of the polygon. So all interior angles of a polygon are less than 180, then it's convex. And then a way we can tell this that if any line drawn through the polygon will only hit it exactly 2 times, so just twice, then we can say it's convex. So I'm going to give an example. If I drew a line through here, you see it only hits it twice. 1, 2. If you drew a line through here, you see it's only going to hit it twice. 1, 2. So we can say that these are convex.
Any line.
Concave polygon, it's a polygon that's not convex. So this is where you can draw a line and it intersects more than 2 times. Can draw a line that intersects more than 2 times. Show that in here. You'd be able to show that by drawing a line through this portion, even though you could draw a line through here and you'd see it do twice. You could possibly draw a line like I did here and you see that it intersects 4 times. 1, 2, 3, 4. So we would say that this is concave. We could draw another one over here where it's going to intersect more than that as well. These are things we've learned previously. So an equilateral polygon is a polygon with all the sides congruent, so all the sides are the same. We have an angular polygon, so this is a polygon with all of the interior angles are congruent. And then you have a regular polygon, and it's both equilateral and equiangular. So it meets both those definitions. Determine or decide whether the polygon is convex or concave. So can anybody tell me about our first one? Is it convex or concave?
Convex.
It's convex. How do you know?
Because if you draw a line, it only passes through the line twice.
Yep, there's no spot where I draw a line that's not going to intersect more than 2 times. We see it intersects 2 times. So on this one over here, which is your second one, can anybody tell me? Coda? Concave. Because you see right here, you draw it through that tail. It intersects 4 times. I should write these out. So you have convex.
Isn't it the same with the next 2?
Concave. So here you drew a line how? I say that, but I didn't. So you see again, you can draw it through the tail. It intersects more. So what did you tell me this one's called? Concave. And our last one? It's concave. And you can see this because you can draw a line through. So here when we drew it, you see it hits 1, 2, 3, 4 times. So as long as it hits more than 2 times, then we're going to have concave. So our first one, you see that it has congruent angles and congruent sides. So what do we call this?
Regular.
We call it regular. How about the next one? Is it regular, equilateral, or equiangular?
Regular.
So why do you say that?
Because all the interior angles and sides are congruent.
You are so close.
Oh, no, because the 2 sides aren't congruent with the top 2.
So we see that these 2 sides are congruent and these 2 sides are congruent, but not all 4. So he corrected himself. So would you classify this as equilateral or equiangular?
Equilateral. Angular.
Equiangular.
I'm sorry, I'm tired.
You're fine. I appreciate the effort. Equiangular. And then over here we have our last one. Is that equilateral, equiangular, or regular? Yep, Cam? It's equilateral. And how'd you know that? Yep, all the sides are congruent. It tells you that these are regular polygons. And in regular polygons, the sides are? What? No, be careful. So the sides are? So congruent, right? Because it means they're also equilateral. So that means I can set the 25 equal to the 6x plus 1. So we have 25 equals 6x plus 1. We're going to combine our like terms, which are the constant terms. So we're going to subtract the 1. We subtract the 1, you end up with 24 equals 6x. Need to get that x by itself, so we divide. What does x equal? 4. Okay, over here we have the same situation. You have equal sides, so we have 15 equals x minus 3. We got to get our like terms together, so you're going to add that 3 to the other side. And then I heard somebody say it. X equals 18. So these two just involve us knowing that if it's a regular polygon, it's equilateral, so all our sides are the same length. We have our first one with, once again, you see that it's equilateral because it's a regular polygon, so we set the two sides equal. So I have 21 equals 5x minus 4. Get like terms together, so we do what? Add 4. You end up with 25 equals 5x. Divide by x equals. Nice job. Okay, over here, we now see that this is still a regular polygon, which means that the angles are congruent. So you're going to set those two equal to each other. 11x minus 2 equals 108. Combine like terms, add 2 to both sides. You end up with 11x equals 110. Divide by 11, and nice job. X equals 10.